Alumni Association and the Department of Metallurgical Engineering, PhD College of Technology, it gives me immense pleasure to welcome you all to the third Dr.G.Padmanabham Endowment Lecture. I request the dignitaries to occupy the dais. We are truly honored to welcome the distinguished dignitaries, respected faculty members, and our esteemed guest speaker among us today. As the saying goes, education is not the learning of facts, but the training of the mind to think. With this spirit, today's lecture brings us an opportunity to gain valuable insights from one of the most respected experts in material science, Dr. Rao. To begin this meaningful gathering, I request everyone to kindly rise for Tamil Thai Valthu. நீராறும் கடலெடுத்தாளமடந்த கேளோகம் சீராறும் வதனத்தை கொடருத காராதல் தெக்கணமும் அதிர்ச்சிறந்த திராவிடன திறனாடும் தக்க சிறு பிறனுதலும் தரித்தோறும் திலகோடை அத்திலக வாசனை போய் திலகோடும் Thank you for the graceful prayer. Now I take the great pleasure in inviting Mr. K. Karthik, Vice President, PhD Tech Alumni Association, to welcome the gathering. In inviting Dr. B. Giriraj, Principal, PhD Polytechnic College, to deliver the welcome address.
Very respected Chief Guest of this program, Dr. Rao, Former Director, ARCA Hyderabad, and Adjunct Professor, Department of Material Science and Metallurgical Engineering, Indian Institute of Technology, Hyderabad, Vice President of PhD Alumni Association, Mr. K. Karthik, HOD of Metallurgy Department, Dr. J. Krishnamurthy, Dr. M. Arasu, the General Secretary of PhD Alumni Association, Dr. D.R. former scientist, Department of Science and Technology, Professor Jayawal, Mr. Bhaskar, the team of faculty members from PhD College of Technology and Polytechnic College, and my dear student friends, good afternoon. It's a great honor for me to stand before you to welcome the gathering for this third Dr. G. Padmanabham Endowment Lecture on Materials Technology for Self-Reliance. We are very happy to have Dr. Rao from Hyderabad, who has kindly consented to be the guest here today to deliver a lecture on Materials Technology for Self-Reliance. So on behalf of PhD Alumni Association, I wholeheartedly welcome Professor here to talk to these audience on the topic Materials Technologies for Self-Reliance. We are really happy to have the Vice Presidents, Secretaries and Treasurers of this Alumni Association who have been part of this body which is organizing regularly programs, endowment lectures and other activities. We are really happy to have Dr. Prasad Raju sir, former scientist from Department of Science and Technology, Government of India here. He has been always been a pillar of support, helping PhD Tech faculty members to apply for projects, and then he always ensures that a good amount of research work happens at PhD campus. So thank you so much, sir, for supporting us in all our endeavors. We are really happy to have the other members who are present here today for the lecture. We have Professor Jaybal here, Professor Bhaskar here, and then other faculty members from the Department of Metallurgy. A small intro about the endowment lecture. As we all know that the PhD Alumni Association is regularly organizing endowment lectures, and in that series of lectures, today we have the third Dr.G.Padmanabham endowment lecture. Just to know who Professor Padmanabham is, I would like to say a few points like Dr. Padmanabha Garu, Distinguished Scientist and Director, International Advanced Research Center for Powder Metallurgy and New Materials, ARC, Hyderabad. So he was with that particular organization, which was aided by DST, and then he passed away way back in 2021 when he was in the US. And in his memory, this particular endowment lecture was instituted by his family. So he is a very good researcher, a technical person, especially in the field of materials engineering. And I would like to just recollect some of the points. He was always a well-wisher of PhD group of institution, and he has always extended his valuable support to all the faculty members here whenever it comes to DST-related projects. And he has also supported people from the PhD College of Technology and then PhD Institute of Advanced Studies. He is an outstanding expert in welding, and he was a member of the Department of Heavy Industries and an expert committee who strongly recommended that we establish a center of excellence in welding, and it was established under PhD Tech and with the Department of Metallurgical Engineering, Electrical Engineering, Robotics, and this particular center has come up very well. And he has also supported us in using some of the state-of-art facilities in his campus for the benefit of our own faculty members. So he was the member of the Research Advisory Board of PhD IAS, and he has offered valuable guidance. A very good friend of Professor P. Radhakrishnan, who established the PhD Institute of Advanced Studies, and then both of them together have done a lot of what I call as research in the area of materials and other sensors and other what I call as requirements for which are required for defense and aerospace applications. So some of the notable accomplishments of Dr. Padmanabham is DAAD Humboldt Fellowship Award from Germany he has received, and then Andhra Pradesh Scientist Award, Materials Research Society of India Medal, and then SP Luthra Lecture Award by the Institution of Engineers, and then Production Engineering Division Award that was instituted by the Production Engineering Division in PhD Tech way back into September 2013. He also received a Distinguished Alumnus Award by National Institute of Technology Warangal, and then Lifetime Achievement Award by SAE India. And then Abdul Kalam Technology Innovation National Fellowship Award by the Indian National Academy of Engineering Science and Engineering Research Board. He was elected as fellow of AP Academy of Science, Telangana Academy of Sciences, National Academy of Science India, and Indian National Academy of Engineering. He has authored about 110 papers in peer-reviewed, high-reputed journals, and presented about 155 papers in national and international conference. Also contributed for about 8 book chapters and then edited few books. He has successfully guided 8 doctoral research scholars and then 30 master theses. He has to his credit about 14 patents, and then many of the patents has been transferred, technology transfers has been done, and he has commercialized it for the benefit of the industries. And in view of his deep attachment with the PhD group, an endowment lecture in his name was instituted by his wife, Srimati Gadireka, 3 years back, and that is how this particular initiative started. And today we are here to listen to the interesting lecture that will be delivered by Dr. Tata Narasimha Rao on the topic the materials engineering. So this is a topic which is of great interest for all the engineers, because if you want to be a self-reliable country, you have to be very, very strong in the materials engineering, and which forms the basics for any engineering field. And whatever success that we have seen over the past few decades, it is because of this particular research on materials engineering. Whatever it is, when we started making materials, when we started making products, automatically the strength of the country goes up. So you can quote many examples, and one of the recent things that attracted even common man was the Operation Sindoor, which was very, very successful when we could make our own missiles and so many things. It's all material intensive programs, and then a lot of things have been done by senior research people like our chief guest who is present here today. So I think the students who are available here will definitely get benefited from his lecture. So we are really happy that we could bring him today to talk to the students on such an important topic. So thank you so much for accepting our invitation and being present here. So let me also thank Dr. Prasad Raj sir for helping us in all these type of activities and all our endeavors. With these few words, I welcome you all once again for this guest lecture. Thank you.
Thank you, sir, for the warm and thoughtful welcome. Now, I welcome Honorable S. Bhaskar, past President, PhD Tech Alumni Association, to honor the chief guest with shawl. Sir, now I invite Mr. K. Karthik, Vice President, PhD Tech Alumni Association, to deliver the presidential address.
Well, good afternoon to all, and I'd like to welcome Dr. Padmanabham, Dr. Giriraj, Dr. Arasu, and Dr. Krishnamurthy sir, and dignitaries of the dais and future members. So today I am here to brief you about what we do with the PhD Tech Alumni Association. So being a Vice President, I am bound with the duty to do that. So the main aim with of the PhD Tech Alumni Association, it was started mainly basically to include all our students who have passed out of this college, and maybe from that day the main aim stood to help the students or underprivileged students with scholarships, basically with their fees and hostel fees and other things like that for their studies. So initially it started in a very small way, and currently the PhD Tech Alumni Association is sponsoring about 50 lakhs to about 200 students per year in the means of scholarship. So apart from scholarships, the PhD Tech Alumni Association also conducts a few programs, one of which is currently undergoing through, which is the Endowment lectures. Second thing, we do a lot of activities like we conduct the GRD talent test from our, based on our great Dr.G.Padmanabham. So where we include all the school students to showcase their talents. And apart from that, the PhD Tech Alumni Association also conducts the year alumni meet, basically to honor all the young alumni who have passed from this institution in the past 2 years. So that is we do identifying people, we do honoring them with the young alumni awards. So this is one of the programs what we conduct. And apart from that, we conduct the alumni congress year on year. Particularly, we have a whole bunch of alumni coming together from all around the world, from within India, around the globe, to meet our students either physically or in a virtual format to give their knowledge to our students. And of course, the last meeting what happened, we had a number of about 110 speakers speaking to our students in the last alumni congress. So apart from this, we have regular programs where we conduct these kind of endowment lectures, bringing the speakers to speak to our students. And incidentally, this year happens to be the 75th year of the institution, and of course we have planned a huge number of activities for our students and alumni. So this whole year, starting from this month of August till the next year September, is going to be a very gala this thing with all kinds of activities taking place for the 75th year of Platinum Jubilee. So with this, I'd like to thank all for this opportunity to explain about the Alumni Association activities. And once again, I welcome you all to this endowment lecture. Thank you.
Thank you, sir, for your insightful words. I now call upon Dr. J. Krishnamurthy, Professor and Head of the Metallurgical Engineering Department, PSG College of Technology, to give us a brief introduction of our distinguished speaker.
Good afternoon all. Dr. T.Padmanabham Rao received his PhD degree in chemistry from Banaras Hindu University in the year 1994. After working at IIT Madras as research associate, he moved to the University of Tokyo in 1996 as a JSPS postdoctoral fellow and subsequently became lecturer in the same university in the year 2001. He joined International Advanced Research Center for Powder Metallurgy and New Materials ARCI Hyderabad in 2003 as senior scientist, and he has superannuated as the director of ARCI in May 2004. Presently, he is a research advisor at IIT Hyderabad and adjunct professor at IIT Hyderabad and IIT Warangal. He is recipient of several awards and honor, which includes Material Research Society of India MRSI Medal in the year 2009, Tokyo University of Science President Award in 2014, Technology Day National Award in 2016, Fellow of the Nano and AP Academy of Sciences 2017, Bangalore India Nano Innovation Award in the year 2018, received from Bharat Ratna Professor C.N.R. Rao, and Material Science Annual Prize in the year 2022 of MRSI. Dr. Rao has been admitted as Fellow of Royal Society of Chemistry through Leaders in the Field scheme in the year 2023. He has been conferred with Honorary Fellowship of Electrochemical Society of India during August 2023. Dr. Rao is founder president of recently established Battery Research Society of India. Dr. Rao has published more than 200 research papers and filed and granted more than 20 international and Indian patents, several of which have been translated to technological developments. His publications got total citations more than 23,000 Google Scholar with an H-index of 61. The average impact factor is above 5 for his publications on the last 5 years. Dr. Rao has been a member of several project assessment, standardization and governing board committees at national level. Dr. Rao is known for his translational nanomaterials research. He has developed novel, scalable and low-cost processes for suspension, powder production of nano silver, nano copper and nano titanium for self-cleaning antibacterial textile applications, high-performance lithium-ion electrode materials, bio and organic waste-derived activated carbon for supercapacitors, and some of the technologies developed by his team are transferred to industry and commercialized. Recently, lithium iron phosphate cathode powder manufacturing technology is transferred to industry for the first time in India, and a pilot facility of 50 kg per day production is established on ARCA campus. Other areas of his research interest include solar energy materials, photocatalyst, diamond electrochemistry, and biosensor and implants. Thank you.
Thank you, sir. It is now time for the much awaited session. I now invite our esteemed speaker, Dr. T.Padmanabham Rao, to deliver the third Dr.G.Padmanabham Endowment lecture on Materials Technology for Self-Reliance.
better. If it is not working, I can request her to change next. So someone can help me, right? Yeah. Yeah, sure. Okay. Good afternoon, friends. I see a lot of young faces, students. I think probably BTech, MTech, and PhD scholars from metallurgy materials and other departments also there. Okay, nice. So my son is also of your same age now. He just completed BTech in IIT Hyderabad and moved to University of California, Irvine. And he did engineering physics is BTech because he loves physics. So I asked him to go to any material. Then he said, I want to do physics. Then he said, don't go to MSc, then go ahead. Then he went engineering physics. But he's doing now medical imaging with algorithms, AI, ML and all. So when I see you all, I remember my son. Thank you very much, Prasad, for bringing me here, because he one day called and then he said, can you go for Professor Padmanabham's endowment? Like I said, yes, of course, because he is a long-time friend of mine and he's almost like my younger brother, because he's younger than me. So he was director of ARSA when I was associate director under him. I was reporting to him. But I have thought, because I'm 6 months elder to him, I thought I will retire under his leadership, because 6 months before he retires. So the things are going so well, and then you know about Dr. Padmanabham, and then he's wonderful. In fact, now I understood a lot of things what he has done for PSG also. It's so nice. And then after coming there from DST, he aggressively started setting up the lab for laser processing, especially additive manufacturing. When by additive manufacturing, today it is a buzzword in this country. When it was just emerging out, he realized the potential, and being a welding specialist, he took up the opportunity and then he established those facilities very fast. And if you come and see all our facilities of laser welding, laser processing, laser cladding, and additive manufacturing by powder bed, and then e-beam lithography, e-beam additive manufacturing for titanium alloys, and now wire arc additive manufacturing, hybrid welding, so many to name. And then all under his leadership he brought. And then there is only one center, but as the head of the institute, including I was leading the battery research team, and then he used to guide and then get a lot of funds to our projects, and then it went on so well. And when the COVID came, can you go to the next slide? So you can see him here. This is the additive manufacturing. You can see a lot of components which are additively manufactured by both technologies, that is e-beam welding and then powder bed fusion. And he was very active in all aspects, not just research alone, but he is very dynamic in other aspects as well. Especially, a lot of people don't know about him, is he's also a very good singer. And then he's so good singer, I never knew that he sings so well, and we used to sit together, and I also do that. That's my passion. So we used to sit together and then discuss a lot about that. And you can see the other side, when the COVID started, then he said that, he called me and said that we should quickly develop some technologies for COVID abatement, or at least control. So then a bunch of technologies we developed under his leadership, and then I was leading from some of the material side. And we developed, first is X-ray scanner, where because in airports they came, and then they asked, because all the baggage and all, when they go, and then people, if they touch it, then the COVID can. So we put a UV-based system like another X-ray. One, this goes through the X-ray machine, and then you have a UV-based system where the bad rays goes through that and then comes out. So those systems were developed, and then we have the auras, which are UV-based systems where you can you just keep your things and then keep for a few minutes and take it out. It is COVID-free. So we put them numbers in ARCA, and then some companies also started. All these products are in collaboration with companies. And then we also developed some cleaning solutions, and even for the disposal of the antibacterial liquid. That is also, you don't need to touch, and then automated. A lot of things. And further to that, we also developed antiviral mask, where the mask is coated with nano copper. Copper kills the COVID virus, and then you can use for a long time the mask, because as the virus accumulates, it just breaks down because the copper breaks it down. So that technology was also developed and then successfully completed under the funding of DST. So with all that, we were going aggressively, and then suddenly he had to go to, for some family function, he had to go to US. And then he's extremely careful, but we don't know the destiny and then what God decides. And then he went there, and then we are still in touch with each other, because I was taking his role in his absence. Usually I used to do that one, being a senior. And then almost 1.5 months, suddenly I was in touch with Madam, Mrs. G.Padmanabham. And then we had a lot of hope, because in US we never expected that this kind of things happen, but it's a destiny, unfortunate, and suddenly went into the this one, special care unit, and then is no more. So it's an unfortunate situation for all the ARCA, because ARCA is lost a father whom we never expected, and it was going so smoothly. And then finally, we used to sit next rooms, and then I used to go every day, twice he used to call me for discussions and all. And I almost lost like my younger brother. And then I was to take the charge immediately as being a senior one. Then afterwards again interviews and all, then I became regular director and all. So the legacy continued. When I took over, it became so easy for me to run the show, because already set everything right. Just I had to keep moving. So directly or indirectly, even after left, I always got benefited because of his things what he has brought for the institute, and how he is elevated to next level. So now, can you go to the next slide? So just go back. So two of the examples, those two you can see, Dr. Padmanabham here and myself here. And then this is one company who transferred technology for some UV-based cabins. And this is another one for the nano copper for the masks. So these are the technologies transferred during his time itself with all the masks you can see. Next slide, please. And then another one, it's the supercapacitors. It is my favorite topic. So supercapacitor is the one, it's like a battery. You can see on the bottom the insert. And it is like a battery, but it doesn't have lithium or any. In lithium battery, you have lithium cathode, which is expensive because you need to depend on the imports, and graphite anode, and then the battery, what you use in your cell phone, in even electric vehicles, they all use lithium batteries. But you cannot go very fast. If you want to use lithium battery in a race car, you cannot, because there you need high power. The moment you press the acid, bang, it should go. But it cannot, it will get heated. So there is another supercapacitor where the charge is accumulated on the surface of the electrodes. So in a lithium battery is the bulk phenomenon. Means the lithium has to go into the electrode, come out, which takes time and it doesn't go fast. But I need energy very fast. So in supercapacitor you have very high surface area carbon electrode. You don't need to have lithium. So that I don't need to depend on import. No need to depend on imports. And it gets charged when I charge it, all the surface charge. And when I discharge, boom, it will come out. It's like a flash. In camera flashes, they use small capacitors, right? So, but you need to sustain for so long a time. That's why we developed the special supercapacitors with a carbon that is derived from petroleum coke, which is a petroleum coke is a waste from the oil refineries within the country, and it contains 5% of sulfur. And people use the steel and the cement industries. They used to use this as a energy metal mess. They used to burn for supporting the industries, and it used to leave a lot of sulfur dioxide, which is dangerous. Then the government banned use of petroleum coke to a level, and then now a lot of new technologies are coming, net zero, and then even now people want to use hydrogen as an addition to the CNG, natural gas, so that you reduce the emissions. So that will come back during my talk. So the petroleum coke, what is given to us, we converted into the very high surface area carbon material, which is conducting, and use that in the form of electrodes and then made. You can see the blue one is Maxwell, that is an American company which is very well known, and the blue one is ARCI, and which is in all parameters equal to what is the Maxwell does. And when Dr. Padmanabham is so pretty, he doesn't compromise in the quality as well as the deliverables. So we have to deliver a bicycle loaded with our own supercapacitor. There is no more battery here. In fact, I could have shown video searching, I could not find it. And you can see Dr. Padmanabham happily sitting and then smiling. And when the CVC director, he was riding the bike with supercapacitor. That means the word self-reliance comes here itself. I don't rely on imports. I rely on our own materials. And the petroleum coke, what has come from the oil refinery, is converted, now burning, into a material which is useful for a supercapacitor, which can give. So the guy who stands now, the director of CGCR, right? I told you, it is like a race car. And then he just rises a little bit, then it just bumps like a horse. That means that much power. So then we used to put controllers to control the speed. Here it is the reverse. We have to put the controllers to control the speed, otherwise it's just jumping. So this is the story of that one, and then we successfully demonstrated during his time. Next slide, please. So what ASA does is a translational research. That means you do fundamental research, and you find something interesting, and you do experiment in the lab, and you find something else which is of really application oriented. But then what people do is they just publish some good paper, because their CV profile will be elevated, and then they can get good jobs, or they can go abroad for postdoc or something like that. But they don't go for patent. If you have a good idea, and then if it is demand, proof of concept is shown in your lab, even at very small scale. If you want to make a material, let's say I give example, battery material, you can do in a small scale, a few grams or so, and then but you know that it performs very well at small quantile level. But it has to go to big batteries which should go into the electric vehicle. That is an industrial scale. But what it is, who will do all that one, that will take a long time and all. Why to waste my time and all. So you just publish one paper and then put it on your CV. Now 200 papers he showed, no, he read mine. So some of the papers also, but at least 20 patents we took out of that one, which are very prominent, so that the technology, the knowledge, what we gained, because see, when I'm doing my job, it is a public money, it is a taxpayers' money is being given to me. So I should also give something back to that one, at least in the form of technology. So some of the examples what I show, with that motive, what has gone up to the industry, and now today we are pioneers in those technologies. Then I'll come back. Wait, fasten your seatbelt and just wait for the results to come. Okay. Now, what is problem in India is, before I talk academia, the left side, that is the researchers, academicians, students, they do the research, excellent research, that's called technology readiness level. That means where we are ready for the technology. It's only 1, 2, 3. That means it's very fundamental up to publication. And at 4, 5, there is technology development and technology demonstration. Development means whatever few grams I made, can I make to 50 grams, 100 grams and 1 kg? It's not so easy. When you are making bigger amounts, you cannot make with the same quality. You make a curry or a chutney at home for a few people, and when you try to make chutney for a large group of people in a party, you won't get the same taste. If you get it, you should file a patent. Then you can open a Chinese restaurant. That means you are doing all your business. That is what is important. Now food business is so big actually. So, but nowadays, if I ask you, okay, why don't you make for 50, 100 people the same chutney, if you made a good chutney, you will say that, sorry sir, I don't want to take that pay. I will make another chutney if you want, but not the same chutney to big one, because you need to mix. If you want for 50 people, for small people you can do just grinding and then all this one. If you want bigger people, you cannot do all that one. Even Salman Khan cannot do with all his milk. What you need is, you need to have a reactor, you need to have a designed equipment where the things should move fast and then mixing and all. Lot of parameters. In fact, combination of food dynamics, everything will go into that to build a reactor. All it is a chutney, right? Then only the technology will come. So that is called the gap between what you make for few people, what you make for a restaurant. That gap is called value of death. Value of death means if you fail to make a chutney for 50 people, then everyone talks. I don't even care. Okay, fine. Or next day I don't remember your name also, because you are only up to 3 people. So people don't want to take risk in country. But in Japan, I was there almost 7 years in University of Tokyo, Japan. If I take any interesting result to my boss, who is a professor, Fujishima, he says let us call patent attorneys and discuss whether it is a patentable or not. So that is what is required. Now with the present government, a lot of innovation is happening, and then we want to have our own products, especially in the present global situation, geopolitical situation. A lot of things are denied. Materials, components, whether it's a semiconductor, whether it's a lithium-ion electrode or the battery. Recently, all electric vehicle companies, they have gone to government and asked, because China wanted to stop the rare earth magnets, neodymium and boron magnets, to India, and those magnets are important for the electric vehicle. And we say that National Electric Mobility Mission, by 2030, 30% of vehicles should be electric. So what is neodymium? Neodymium is rare in the country. In the beach sand, Kerala, and Andhra Pradesh, we have neodymium, which is rare earth. But we need a technology to extract from its raw material to the neodymium metal, high pure. Similarly, we have gallium oxide for our defense missiles and all. But again, you need to have gallium where? In America, if you go, aluminum industry, the byproduct is gallium. But you need high pure gallium of 99.9999. And the purification technology is required again a value of death. So we are not ready to cross the value of death. That was giving all a problem. Now, you young people should realize that this is, whether you like it or not, you have to do this, because now even our students are denying us, a lot of people, even my son is every day I will say whether he will stay there or come back. I said that if you want to come back, don't worry, my PF is there, I will repay the loan, but you come back. Don't jump from the 7th floor and all this. So he said, so because the situation is like that, and people are not interested to stay outside. And we have plenty of opportunity within the country. So be ready for these technologies, and my last slide will show what we have done at IIT Hyderabad. So the industry is presently, what they do is a car maker, an electric car, you buy the wire, just knows it from the China, and you buy the battery from the China, and only series parallel combination, make a battery pack and put it in the car or scooter and all. 70% electric vehicles are scooters within the country because medium, middle class people. Then we saw before last year, there are so many scooter fires in the country. Okay, and people are so much worried to buy electric scooter. You want to buy, but it's firing. Because they buy the compromised battery cells imported, and then if 1 or 2 are faulty, then whole thing will burn. And it is like a bomb, actually. People died. And people don't know, and they take the battery pack and then go to their cell phone in their flat and then they charge it. People died in the house because they don't know how to use it. And then at that point of time, the scooters are firing, people are dying, the government formed a committee, and then I was chairing that committee to make the amendments to the existing standard, that is AA156, and we said that these are the parameters, like if the temperature goes to 60 degrees centigrade, you can have an alarm so that the visual alarm audible, so that people can use a scooter and borrow, they'll run. So there are series and parallel combinations, these cells, small cells, and then every line should have a fuse so that if something gets heated up, fuse will blow. So line ambulance again from last year March, there was no fire, at least, but that is not enough.
what is required is you should make your own battery within the country so that your batteries are standardized by BIS, and then I know if some battery fails, I know whom to catch. There's Amar Raja, Red Z or someone. Now you can't catch anyone in the Chinese. They'll say get lost. They'll say if you want best battery, you give me more price. But scooter is one because kitna data is because you have to sell your scooter at low cost, so you compromise heavily. Now, so industries do that. So the gap, unless the gap is filled, then is not our technology as self-reliance. So ARCA does fill the gap, at least to some extent, and that is the job of ARCA. Now I'll go fast. Next. This is the one what in another form people keep, this is the laboratory research is invention, and successful commercial launch of the invention is innovation, and this is the valley of death. You want to die or go that way. If you don't go there, then we are lost, but the country needs to go that side. That is must. Next. So I get very quickly, so now I go very quickly because I put my slides because I saw the profiles of the faculty in PhD. I thought people should not get bored. And some people work on photocatalysis, some people work on metallurgy, additive manufacturing, and of course, battery, is some people are there in energy materials or no? So I think you should start after my lecture. Because that is my core. I also need to show what can be done in the country because the National Electric Mobility Mission is a big one. And ARCA is in the front line. And recently we got 60 crores project under Maha EV scheme from ALRF. And we are setting up 2 megawatt pilot facility of battery in the present direction of Dr. Vijay, who is the present director. So those people, now Silver Keys right away, and Professor Avara helped that time to establish these cartridges in some of the various health clinics and all. So Silver Keys right away, and we can use silver on any kind of substrate, and then there is a filter candle or anything. But what we did is, here the success story is to put on the fabric. And your socks smells after second time, third time if you wear it, because the bacteria what goes to your sweat or socks, then this bacteria is not smelly. It eats away all the triglycerides and organ matter from your sweat, and it gives out the small people gases, the mercaptan and formaldehyde, which are very bad smelling at very small concentration. If you kill the bacteria, no smell, because there is nothing to decompose. Of course, you cannot wear the socks for 1 month, then other problems will come. But at least you can sit with beside your next friend who is wearing third or fourth time, right? So silver, and we developed the nano silver technology. You can see is not just small suspension of 100 mm. Initially it was very small concentrations and nanoparticles, and this the company wanted 15 liters capacity reactors, and this took long time, and we had to work with some fluid dynamics guys and some reactor guys, and finally we made it. And then they run the multiple reactors, and the silver what is tested, validated, it doesn't go bacteria, it has gone to, you can go to Color Plus and ask silver fresh. These shirts are available, and now Jockey is also putting out the inner. So it doesn't allow the bacteria to grow, at least the skin irritation now will not come. And the second one is titanium dioxide, photocatalysis people, titanium dioxide which kills bacteria under light or any organic matter. If you have fabric coated with titanium dioxide, now if salad or rasam falls or coffee or brandy, whiskey, anything what falls and then makes your stains on the shirt, then you remove the shirt and put it in sunlight, and in 8 hours of your sunlight, it just disappears. Provided there are only stains. Stain means it's not, you cannot put your shirt in a sambar and then say it should be cleaned. It's just sambar stain, I'm telling, right? It's just what falls. So again, self-cleaning. You don't need water, you don't need sunlight, you don't need detergent, you don't need power. So just put it in sunlight. So you can have two pants of 2 colors, so that people will have the changing the pants with titanium dioxide. Today, so put in sunlight, tomorrow, that's all. 1.4 million people, if they start using this technology, say how much water, right? And some people said that that's why what happened. They started putting on jeans, the splash of a flying machine, you have sun-washed jeans. The jeans coated with titanium. They are nanoparticles. You don't see titanium dioxide actually. They are everywhere, but they are nano because you cannot see visible light. But we developed some binders so that the binder sticks to that one. And then if you use jeans pant, you don't wash 3-4 times. And if you use titanium dioxide, you never wash. So you sell a lot of money. So people started talking about where use and save environment. There was slogan in UK. So these are the success stories of what we have done at lab scale and crossed the valley of death and took for the 50-20 liters capacity reactors, which was then taken by industry. Industry otherwise they don't even look at you. And for this both process we have patent, IP, intellectual property, patents, and then unless you have the patent, then they don't take the technology because if that is already done elsewhere and they will sue and then this guys have to pay use penalties. Next one please. Now I just come back to batteries and so far whatever you see on the roads, I know many of you must have seen the Tata Tigore or you have Mahindra, Hyundai, what all brands almost come with the cars with batteries. They run lithium batteries because they can only with small size, lithium being the third element, they can small size but huge energy can be stored. You don't have lead acid battery for the same energy because you don't use lead acid batteries. Lead is the element. So now, this, with lithium batteries, all these brands run on the Indian roads, but they are all imported. And our electrical and electronic companies, they import them and make the battery packs and put it in the car and the car will go. And if you make any kind of compromise and the car, the work cars also blown up. Now, and scooters and travelers also got, and you can see bus, it was being inaugurated by Honorable President, Prime Minister, and that was also with batteries. Now, of course, hydrogen technology is coming, so the battery and hydrogen, they're playing the balanced role. So the point here is, unless you make your own batteries, then there is no future for this technology to survive, as long as you depend on the imports. You can make your battery, now the plants are coming, Amar Raja and then Exam, they're making battery plants, but the material inside is a powder which is formed in the form of slurry and coated with electrofoils, aluminum and copper, and then roll in the form of jelly rolls and put it in a can and then give it to wine. That's the battery, what you see. But inside, it is a jelly roll which is a long strip of 1 meter or so, cathode, anode, in between a separator. They're all coated. So the material is kind of powder, what is made in the form of slurry and coated. That's what is inside battery which is giving energy to you. So the material is very important because lithium, we don't have lithium in the country, that's what is real slogan. But now lithium is here in Jammu, Kashmir and then somewhere in Bihar and all. But we don't have extraction technology of mining of the lithium spodumene or other clay kind of material and then extract the lithium. Today I am very happy that I So there are no people extraction metallurgy people. IIT Hyderabad, we keep on advertising and then we keep getting every year one extraction metallurgy. Because metallurgy people with extraction, earlier it was not so attractive, but it's very, very important. Right? Next one. These are the files I was talking. In the form of jelly roll and then you can see that battery inside and then the materials whether it is lithium iron phosphate or lithium titanate, these are the materials and the voltage comes from anode and cathode. This is the voltage difference. So you choose the anode and cathode in such a way that what voltage you want. Okay, so but the materials have to develop within the country, that is what. So we took that as challenge because to supply to Amar Raja or the battery manufacturing companies the material, and the material has to be developed within the country. So we made that material in a large scale crossing the valley of death and showcased that we can make in tens of kilos and then gave the technology for the first time in India to a company. And now all the companies who are going to make in the next 5 to 10 years, they need lithium iron phosphate and these are technology what we have. There are some issues because this guy who is now ready to he has now 100 kgs of the materials on his land, but unfortunately to inventory, but unfortunately is still the sales they keep lowering the price and this guy has to match the price. Otherwise the company will not buy because company has to be salary to the companies. So the government is now intervening and seeing that they can use subsidies even for the component manufacturers, not only just the bigger players in the form of PLI scheme. Next one. Next. So, this one. So, when it comes to technology, lithium iron phosphate, LiFePO4, is very simple to make. You take iron phosphate, you take lithium carbonate, put them together, heat it, the carbon dioxide will go, it will form LiFePO4. Then what are we doing? Why do I say that the first time in India and all? But the lithium iron phosphate is a insulating material by nature, and for any electrochemistry, electrode must be conducting. But this material only can take lithium and give lithium when you charge and discharge. So, you make a small particle so that the diffusion length is very short so that it doesn't need to travel within the particle. So, it's a nanoparticle, 100 nanometer. And how do you get the current? You do a carbon coating so the carbon is conducting. So, you can see there, the bottom you can see, the particle is uniformly coated with very thin carbon so that you don't need to have more carbon because the energy density will come down. I want only lithium iron phosphate to be more, but at the same time I need carbon. So this is the best option, and our technology, what we patented both in India and abroad is that how to get the uniform carbon as thin as possible so that it's conducting, and how to control the size uniformly. So that all the powder what you make in kilograms, 100 kilograms, that should have the same kind of composition one. That's a chutney concept. You have to make a chutney for the 50, 100 people. You need huge amounts, but it is the same taste. Here, you have to make tons and tons of the material with the same kind of morphology and phosphate. You can see the other side, and we successfully made the material LiFePO4 even at 10 kg. But unfortunately, it is imported, so the cost is very high because the machine itself is how many crores? 100 lakhs, 1 crore. So, if I want to make tons, how many machines will we import from Germany? And when Germany starts exporting, then you can't. So then what we do is you can see the left side, the iterator that is designed by ourselves, and then we got a vendor in India, and then we make the design, and the same thing we did it with 3 lakhs. Now, if you see the data what we get on the foreign machine and our Indian machine, is also. So the self-reliance word comes this one. You make your own machine, you make your own material, you make your own chutney, don't depend on to the maximum possible. I still have to depend on the lithium carbonate, which is the input material for lithium and phosphate, but that I cannot avoid. But now, Jammu Kashmir and all, we have lithium, if extraction metal is possible. Now that recently we got a center of excellence, I got along with NML and all, to extract the materials from sources, primary, secondary, tertiary, and we also prepare lithium from the spodumene, that is the Jammu Kashmir one. We have the technology for that, but at night Hyderabad. So now, this is what, you need to have manufacturing machines, you need to have the material also. For example, if you import the basmati rice and you import the cooker and make the biryani, better you import the biryani itself. It is too expensive. But at least I should start growing basmati rice in my own paddy fields. If I cannot make the cooker, half the problem is solved. And if you can make your own cooker within the country slowly, then 100% solved. That's the Atmanirbhar, self-reliance. People have to think, mechanical engineering, materials engineering, what kind of machines I will build and what kind of materials I will build. Can I make a system out of that? That's what we need. Now go next one. So we got easy adoption of technology because we make the machines in India. Now the company who set up a plant, a 50 kg plant on a ARCA campus, every machine what he has got furnace, everything is made in India only. and he got it fabricated within the country, and now he's running. Next one. This is the technology what we transferred to the company. Then next, in 2021. And the production, this is actually the production of the, what we started 100 grams, now there is a plant with 100 kgs in 2 sheets, and this is inaugurated by Niti Aayog, Dr. Saraswat and Dr. Anil Kakot, who is a commission, is our government chairman. And you can see the materials. So this is a success story now. So what is benefit to ARC to all that one? And we develop technology, and then for 100 grams if we stop, we get nothing. But since we crossed this value of that and we could show 20 kg production, the technology is 3.5 crores we got. 3.5 crores we got for the selling of the technology. Your knowledge is power, wealth. Then we also get royalty on every kilogram what we sell, India and abroad. If we really become successful, maybe in 10 years we get a lot of money even without the assistance much of the funding agencies. So this is what? So where is lithium? I am sitting on a salt flat. The previous one is what? What slide previous? Okay, next one. So I told you, right now lithium is 2 sources. One is the hard rock that is in Jammu Kashmir. Another one is the salt. And this salt dissolved, all the white is salt in Bolivia, where during the evolution of the earth, that time, the seabed has come, that's the story what they say. So that is all the sea water, when it dries, it becomes like a flat, it is perfect flat, at 200 square kilometer, and when it rains, it becomes like a ball, just mirror when you see this from space. It's so flat, it's like a mirror. When it evaporates, you can see the grains. The water goes and you can see the grains, it's like a thing. And then when we went in the car, there is no road. You don't know, it's like a sea of salt. And we have to see the small mountains are there, other side. There's a companies there where they take the, why I'm telling the story is the salt contains lithium. Our salt contains sodium chloride, this is a lithium chloride, with some sodium in our smoke. So, but it's a world heritage, so they should not disturb the pump. End of this one, where the mountains are there, there's a company there where they pump the water into the ground and take it out with the salt water, and that's called draining. And that water, they extract, it's very easy to extract lithium. So I went as an advisor with some Indian company, because they want to establish the company for production there, because it's getting all the mines and spoiling our environment. And set up the country so that you are doing jobs for their own people, very small country. And then you make the lithium carbonate and then export to India. So like that, in Brazil also at times, Brazil, Bolivia, all the way from India to this one, 15 to 16 hours flight. It was shaking because sea is also there. So luckily it was not Boeing, it was Airbus, A320. So next one. The supercapacitor, I said, the first slide what Dr. Padmanabham was enjoying the ride of the bicycle where we made the supercapacitor. That is made in this form. And next one. And supercaps are not good for the race car is okay. Race car will go in one small length, but distance. There is a long time cost like what we use. Those are not good because it may not go more than 50 kilometers or 100 kilometers because it gives high power, but it cannot sustain because only surface charge. So now what in China, although they have lithium, they have the buses which are powered with supercapacitor, which is very cheap. You need only carbon. No need of lithium, no need of cobalt and all. And the bus, whenever the bus goes to the bus stop, the power cable comes on the top and touches the cable, and it gets charged in minutes because it's only surface charge, very fast. And also get discharged, it will go very fast. So every bus stop will have a charging one. By the time passengers get in and get out, it gets charged. So this is the technology. So now next one. And we started making from jute derived, jute stick is a waste. So we took jute stick which is very cellular in structure and we converted it into carbon and you can see the raw material is like graphene with huge surface area which is conductive and we made supercap. And the area under this curve is the potential and current. Area under this curve is the how much energy it can store. The red one is commercial and black is ours. We did excellent job, but the scales are not matching. If you take jute stick, even the Calcutta and all the coastal area,
but the conversion of the carbon is only 30%, so it doesn't make economic sense. Then the HBCL looked at us and they said that you know how to convert to carbon for the supercapital, so we will give 1 crore to convert the petroleum coke which is a waste. And we did it, and that was next one. And there's a petroleum coke by HBCL, and then we did all this one, and then finally you can see ARC and commercial capacity are almost equal. Next one. And with the money of HBCL, we set up a line, and then with all
One equipment again, I am telling indigenization of equipment. This equipment we forgot to buy, and then Dr. Padmanabham that time he said that now you make yourself because you missed it. Then we went to a vendor and then we got it made, and then if this is not there, the whole chain will be stopped. This is only essential for supercapacitor, not battery. And now this is called flattening machine. Now this machine was made within the country with our vendors. So we can do that one. We can do it because they are not rocket science technology. They are all simple machines.
but we need to have a will to do that one. So now in the Maha-EV project, we also put one vertical as engineers for the equipment also, while we do for the materials technologies also, and we got some vendors collaborating with us to make the equipment exactly what you import. So next one, this is the bicycle what I showed. Now the myself.
Now is Dr. Vijay, who is now the present director of ARCL.
He's a strong metallurgist also. He works on various steels and super alloys. And now he also makes powder production because powders for L2 manufacturing also we have gas atomizer and make super alloys and steel powders by this technology. Next one. And then what we thought is we want to choose a material which is like a battery with a high energy density, but supercapacitor like high power. Because the drones, for military applications, when you have the surveillance drones, the drone has to go vertically up, not like a flight. And you need the high power to lift it. In general, they put a supercap and a battery. Now what we want is, can we do in a single device? And we did it, and then you can see,
In 3.5 minutes, you can charge the battery. Unlike ours in conventional way.
and he's published in Journal Power Sources a few 2-3 months back. And then now we are working with a drone company whether this can be used for lifting as well as surviving for some time until they finish their job. Next one. And what is next is, I was telling you, sodium lithium ion is very difficult because we don't have lithium. Although we have lithium, it may take another 10 years to establish the technology to extract lithium from the sources what is there in Jammu and Kashmir. And also it is a strategically difficult place, there are masses, there are villages of that. So in the meantime, what is alternate to sodium? There is lithium, sodium ion battery. Sodium ion battery, sodium is in plenty. Three sides of our country is only water, seawater, and lot of sodium chloride. So sodium ion battery makes sense for our country, although it has 30% lesser energy density than lithium, but it doesn't matter. If your scooter is going 200 kilometers, you go to 180 kilometer range, but we don't go much long distances. Similarly, we don't go, like in America, they go 1,000 kilometers also they drive. But here maximum go to Vijayawada or Warangal from Hyderabad. And in your case, maybe I know. Do you go to Madras by car? I don't know. So anyway, what happened is China is always aggressive. They have enough lithium, they have enough rare earths, but still they already demonstrated the sodium ion battery before anyone can do it. A car with sodium ion battery is already demonstrated, and still you are working. Actually, ARCA was developing material lithium sodium ion phosphate. Again, lithium ion phosphate on a large scale. So the next one is sodium ion battery, and that is going to come. Next one, please. So for sodium ion battery, you need to have a lot of battery materials and a lot of research scope is there. Next one. And what you need is, just go back. Where did I put, next go? Yeah. So go back, sorry. So sodium ion battery, I said the source is a lot of seawater, sodium chloride, and he's my son actually, looking at the future of sodium ion batteries. So I just put this photo for the sake of entertaining you. Next one. Now, I told you that lithium ion battery, then next generation sodium ion battery which is competing, which is good for the country, But parallelly, hydrogen economy is coming. Now, everyone talks about green hydrogen. How many people heard about green hydrogen? Lift your hands. Hydrogen? Only faculty, students. Guys, I know. Yeah, so green hydrogen. Hydrogen is, you know, right? When you burn hydrogen, what happens? When you burn hydrogen, what happens? Product. When you burn carbon, it takes oxygen, carbon dioxide. When you burn hydrogen, H2O, oxygen will pick up, H2O is water. That means if you can run your scooter or bike with hydrogen, it takes oxygen from the air and you can collect water in your exhaust, not CO2. There is a beauty of that. But where do you get hydrogen? Where do you get hydrogen? Where is the source of hydrogen? I said sodium chloride is seawater. Hydrogen? Also, seawater has got all water. The water electrolysis is the one what is used for hydrogen production. But the other one is methane, that is a gas reforming with the water, steam. That also gives hydrogen, but it gives a lot of carbon dioxide, which is not green. So the green hydrogen is not, the hydrogen doesn't have color, but green is because you use solar power and then due to the electrolysis cell and give the energy and split the water into hydrogen oxygen. So it's a green method, that's why it's called green hydrogen. So this green hydrogen is talked everywhere and then people are making electrolyzed. Luckily, India has already this technology as electrolyzer, like Sikri-Karai has started and then a chloralkali plant on highway and they use electrolysis only of seawater. It's sodium chloride water, not exactly seawater. So these technologies are not coming for India. So we are already there competing with the foreign countries to produce hydrogen and the equipment of electrolyzers. There are companies who sell electrolyzers. But the only problem is the water. You need clean water for the hydrogen generation. Although I say that 3 sides seawater, and you cannot do the seawater electrolysis. A lot of them, we have a lot of minerals, bacteria, sodium, chlorine, and if you want oxygen, chlorine will come, which is not good. So these are the problems. So what you need, people what do they say is, you desalinate the water, and then make the clean water, and then use it. Although you call it green hydrogen from the solar photovoltaic energy, you still have to desalinate very against solar, but huge energy, and the cost of hydrogen will go very up. Unless the cost of hydrogen is matching with your diesel petrol, that is $1 or $2 per kg, it doesn't make sense. But right now it's $5. So, you need technologies to, and one side you need clean water. We don't have water. India is water stressed country. Where is all the water coming from? So there is the previous slide I showed, there are materials which are selective to split the water directly from seawater, and a lot of research is going where I can use seawater and electrolyze rather than using the desalination, which is very, very costly. So there is a lot of scope for this hydrogen economy. Next one. And we have desalination routes what people use, which is expensive. Next one. And you can see this is the direct source of seawater, direct seawater electrolysis. People are doing, and then there are demonstrations, but still we have not crossed the value of that, and if that happens, our green hydrogen will become very cheap. Next one. Now, the one problem, let us say one problem is solved. I got the material like in the previous slide, and I electrolyze seawater directly. Fantastic. But still it should be green hydrogen. That means I need to use a solar energy. That means solar PV panels, rooftop panels now, and that gives energy. Of course, the cost of unit of solar energy is almost on par with the grid energy as 2.5 or 2.4 rupees. That's okay. But if you want the national hydrogen mission goal is by 2030, you need to have 5 million metric tons of hydrogen. That means you need to double the capacity of the solar panels. There are solar panels that much. You need to cover huge areas, and we don't have silicon made in India. So, can you do the extraction? Already we have so many panels, and they are already more than 10 years. After 12 years they become obsolete. So can we recycle the silicon, pure silicon? What is used in the imported panels? So that is what is going on. The huge money is being given to recycle the solar panels and take all the available elements. So the silicon, you take it, you purify it, remove all the materials, and then take the silicon, crush it, and then melt it, and then do the electrolysis, it's called electro-refining, is again extraction technology, and make pure silicon and then make again the solar panel. And this is called urban mining. That means you don't need to go and then do from the primary sources, but recycle the one which is already good, which is imported. So we have huge stock that is going to come in the next few years, 7 years. So this is the technology recycling. So now if I have a recycling of silicon and make the panels, and if I have the seawater electrolysis, then that makes sense for the green hydrogen to compete with $2 of hydrogen cost per kg. So metallurgists, as I said, traditional metallurgy like physical metallurgy, powder metallurgy, they're all okay. But the huge scope is also there for the extraction metallurgist, even more than ITs. Now IT is falling down, and all the core areas are coming out, and metallurgy is one among the metallurgy, extraction metallurgy. Even you are a powder metallurgy, then later on you can shift extraction metallurgy. In India, you are used. Government of India just last week or 10 days back, the Ministry of Mines has announced this under Centers of Excellence. This is 1, 2, 3, IIT Mumbai, IIT Hyderabad, IIT Dhanbad, IIT Roorkee, CSR IMM to Bhubaneswar, CSR IMM Jamshedpur, and IIT Hyderabad. So luckily we have 2 in Hyderabad, one is our IIT Hyderabad and LFTDC. And all these we competed for getting grab this Center of Excellence, and when all these are selected by Ministry of Mines, all these will have, each center will have their own methodology and targeting some of them. For example, you want germanium, and I told you in the beginning, and you want germanium, gallium arsenide, you need high pure gallium. Can you make gallium there? Hindalco makes aluminum, and the byproduct is gallium. But purifying the gallium to the gallium arsenide level of 99.999, that's the technology that is required. So we propose these kind of things. I tell you one last example. We import everything because we don't work on that one. We have all the sources. All these materials where the sources are there, like Redmond he said, from Redmond a lot of things is extracting, and that's a bit of my technology. You should think about, if you cannot do that by yourself, being a technician, collaborate with some industry, collaborate with ARCI where the translation is possible. Prasad Rajwar is there. You will scale up. So, what is required is all these critical elements, what we call, where the sources are there, but we should have know-how. And we went with an argument that, for example, gallium is there, we can also make gallium, 99.999, but you cannot compete the cost. Let's say Hindalco stopped that one, because they imported gallium. But suddenly if China stops the gallium, you don't have gallium here. And even you want to fight a war, you don't have the results because gallium is there. So what we said is, we should have a know-how within the country that I can make biryani. When biryani is required for the army, I can make biryani, that know-how should be there. So I should have the know-how to extract gallium of 99.999. So when the situation arises, at least this technology is ready. Otherwise, that time if you start from zero, it will have. So these are some of the technologies which are strategic, and some we are doing for the civilian sector. One small important for fertilizer, I don't know how many are farmers' children, and for farming you need fertilizer, NPK fertilizer. Nitrogen, P is phosphorus, and K is potassium, right? And potassium, what we use for, potassium is required for the growth of the plant, and potassium is required for the human being also, we have to consume. That's why non-vegetarians should take vegetarian food, because all the plant food, the plants extract potassium from the fertilizer. And the animals doesn't eat fertilizer, the animal doesn't eat NPK. Without potassium, we'll have a lot of problems, right? So, NPK fertilizer, the potash 100% is imported in the country, 80% from Canada. If the potash supply is stopped, the country will stop 1.1 billion people, maybe 6 months or so. So this is one of the things what we have potash sources, like feldspars and then gluconides. Even for the biological, human, whatever we exceed, that also contains potash. Can we develop a technology for the human race to reconstruct the potash? Now these things are coming into the picture, because we see that the whole country is getting polarized. No one knows who is friend and who is enemy. So we should be ready to survive, right? So there is a huge stress, but take the challenge as opportunity, then you give the employment, and then be in the country, and then do. There's a huge opportunity for the country, a lot of money being spent for this one. Thank you so much for this opportunity, and any questions, I'm okay. Now you can clap. Done?
Any questions from the audience?
If one person starts, other people start. I don't. Voltage doesn't, because if you see the energy scale, lithium versus any material voltage, and graphite, carbon, that has voltage of 0.5 volts versus lithium, that's why it's called anode. So with lithium you cannot use because it's very aggressive. Any metal that stores lithium is used anode, and cathode is on the top part where that's voltage is 3 volts, 2 volts, 1 volt. So right now 3.2 volts battery what we use for lithium is lithium and phosphate. So use carbon and then lithium and phosphate. This energy difference is 3.2 volts. Yeah. So when you use graphene or carbonatics and all, the voltage doesn't change much. It's only the energy supply, that is power, that can change because graphene can go very fast. But otherwise, not much difference in that one. Actually, it's not single-layer graphene, it's only a multi-layer graphene. Otherwise, you need to have a space to go in and then sit. Yeah, so when you if I remember Li5C, is like alloying, you go and sit, and when you charge it, you go to the lithium into graphite, and when you discharge, you will come out, and then go back to the lithium and phosphate. So, intercalation and de-intercalation, and you discharge. That's how it happens. That's why you need graphite carbon, but not amorphous carbon, because it doesn't have. But for sodium ion batteries, the interlayer distance is not enough for the sodium is a bigger one compared to lithium. It cannot go in and come out. So either you have expanded graphene with some new technology or hard carbon where dissolved carbon, the graphite sheets are dissolved so that there is somewhere the sodium ion will go and then sit. So this is called hard carbon. Now that's what is being used for the sodium ion actually. Pure graphite does not for the sodium ion. What is there for the lithium ion?
You mentioned about sodium ion likely to take over lithium ion.
Yes, sir.
How does the cost compare them both?
Sir, at the moment, yes, sir, you are right. One is, at the moment, the cost doesn't change much because you don't have lithium technology, sodium material technology. But if you take 1 kilogram of lithium iron phosphate and 1 kilogram of sodium iron phosphate, around more than 100 times cheap this is. And it only makes some 30 to 40% cost difference because remaining battery is still all imported. Not very low, it is almost 80% of what lithium ion battery does. That's why the car could go. So, and charging is much faster than lithium actually. Because
What about safety?
safety is much better than lithium ion. Lithium ion, yeah.
Then why is it not catching?
Because the challenge, like I said, the anode itself, graphite doesn't work. You need to have a hard carbon which has enough disorder at the same time conductivity. So that is one part. And the cathode part, lithium iron phosphate like sodium iron phosphate, it is not so stable like lithium iron phosphate. Once you take lithium, by the time it goes back, its phase changes. So it has to stabilize the doping. So a lot of the sodium ion is a long time. But now once it came into the picture that we need a lot of energy and people started working with that. Now it's working. In India, the companies are looking for doing. Otherwise, they give a lot of money for us. To develop lithium materials for the cathodes. But unless it scales up, then you cannot see the fruits. Then we can see the difference. And at the same time, the cost of lithium will go up. It's like hydrogen. You know Professor Srivastava. When I was doing my MSc and PhD in Banaras University, my next door is physics department, I was in chemistry. He used to drive motorbikes with hydrogen. And people used to make fun of that hydrogen is so expensive and then he's just for MNRE money he's doing that one. But he's a very dedicated man. Till his last day, he was sitting in the office and I used to go even after his once in a while, and then, because I know him very well. So I used to say that don't make fun of anyone. One day the oil cost goes so high, it matches with the hydrogen cost. Now that's what happened now. That time used to be 8 rupees, 10 rupees, petrol and diesel. Now it's 110 rupees. And the hydrogen cost is only, now of course $3 floor, but it will come down and then it will match. That's why people are jumping into hydrogen, not hydrogen. And you need to have an import substitute, you don't want fossil fuel, you need minimum carbon dioxide emissions, net zero by, we signed the agreement, Paris agreement by 2070, we will become net zero or something. So all this, carbon dioxide is a big issue. So the technology for carbon dioxide capture and converting back into the ethanol or methanol, those are all the technologies what is again for future. Huge scope and huge money. India has not enough money to fund. Now we talk about the hundreds of thousands of crores for each kind of mission. But only thing is we need, when we see the proposals when it comes, no, really, we don't really get good proposals and we cannot just like the fund the proposals, they are not just because government is a taxpayer. So that's what we keep telling all the people that you make good proposals. And now the ISERs have come, IITs, more IITs come, and now that is increasing. But now the DST has luckily came with hub and spoke model where, because I used to write, when they ask me of doing research, I say that you have only hardly 1 or 2% young people are in the IITs, and the rest of all the people are, you say young people, India is a young country, all these students, young people, what will they do if you don't support? So now in the hub and spoke model, all the state government colleges can get in touch with IITs, and IITs will mentor, and then the funds will come. So we got IIT also got with some few spokes, including some state government. So now the government is trying so, and there is Prime Minister Fellowship now, professorship, and the condition that this professor should go and work only in the state government issue. These are very positive trend and then good ideas, so how it will be implemented, I don't know. So everyone has got, whether you are in a IIT or whether you are in a PhD, whether you are in a state university, you have your own opportunity for the future. And I think after the BTech, whether you are here, I became director of ARCA, but I came from very small village. Until 10th class, I didn't see a train and Telugu medium only. So, nothing stops you, but somewhere you have to work so hard to cross the activation barrier. There's Arrhenius equation. If you don't cross the activation barrier, you cannot go to products. If you want a good quality product, or good life, good car and all, then you have to work somewhere on. I could not get opportunity in my early days, but when I went to Japan after MSc for 7 years, I used to slog 14 hours a day, and I used to understand now like that. Okay? I think with these stories, I should stop, otherwise you will drive me out. Thank you.
Thank you, sir, for sharing your innovation, researches, and memories with Padmanabham, sir. Your insights on material technologies for self-reliance is truly inspiring. Also, your lecture created a curiosity on developing battery technology and extractive metallurgy. I now invite Dr. G.Padmanabham, sir, to honor our guest speaker with a memento.
So I exceeded your time. No, but I thought whatever is young people
I now request Dr. M. Arasu, General Secretary, PSG Tech Alumni Association, to propose the vote of thanks.
Everybody order present here. It's my pleasure to thank to the chief guest, Dr. T.Padmanabham, Research Advisor, Department of Materials and Metallurgical Engineering, IIT Hyderabad, for delivering the third Dr. G.Padmanabham Endowment lecture on the theme of material technologies for self-reliance. Thank you, sir, for enlightening and thought-provoking lecture which brought new insight into the field of material technology and research development such as supercapacitor material development, sodium-ion batteries. Thank you, sir. Thank you for the valuable time. I would like to acknowledge Mr. Sandhya, daughter of Dr.G.Padmanabham, who is currently working as Anisa as an alumnus of PhD College of Technology, BE Computer Science 2008-2012 batch, along with his daughter Rita, wife of Dr.G.Padmanabham Garu. Both of them have voluntarily established this endowment lecture in his memory. Our sincere thanks to them for their generosity, for financial support and commitment for conducting this lecture. Thank you, madams. Furthermore, the family wishes to institute the endowment for a memory lecture in his name. We deeply appreciate their gesture in honor of Dr. Padmanabham's legacy. I wish to thank our patron, Dr. Padmanabham, Principal, PhD College of Technology, for supporting to organize the guest lecture program. We are very grateful to Dr. D.R. Prasad sir, former scientist, DST, Government of India for gracing the occasion. Thank you, sir. My sincere thanks to Dr. B. Dillard, Principal, PhD College of PhD Polytechnic College, for his participation and delivery of welcome address. My special word of thanks to Dr. Mr. K. Karthik, Vice President, PhD Government Association, for delivery of personal address. My special thanks to past President, Mr. S. Bhaskar sir, and also 6th batch, and former Professor Siddhanarayan sir, and my faculty colleagues for joining this wonderful lecture. Last, a big thank to all the students, guests, volunteers for their enthusiastic participation and support in making this event a grand success. My special thanks to professors and faculty of Department of Material Engineering for coordinating and conducting this lecture, and all the engineering graduate and undergraduate students for participating in this lecture. Once again, thank you all for your august person. Thank you. Have a nice day.
Thank you, sir, for expressing our collective gratitude to all who have made this event a great success. All are kindly invited to join us for refreshment out by the cinema.